Morning class, we're going to be talking about related rates today. So, do any of you guys remember lessons from before, like yesterday's lesson? Anything? Anything at all?
Not really.
Derivatives?
No.
You don't remember? What are you guys laughing about?
Nothing.
Brendan! Hey, Brendan! Wake up! Hello, Brendan! Wake up! Brendan, wake up! Get up!
Where am
Oh my
I?
gosh, this freaking marker. It's not even working anymore. I should make good use of this.
Oh my lord!
So, as I was saying before, Brendan just... Oh, go get a marker.
Hey Albert. Hey, what are we doing right now?
Dude, I want some tacos.
Hey. Do you hear that?
Hear what?
That's the sound of no one caring.
Brendan, your niceness level is the limit as x goes to 0 of 1 over x.
Seven.
No, your niceness just does not exist.
Dude, you are a batch of cookies.
Alright, I got a marker. Hey guys, open your page to 462. Okay, who wants to read the problem out loud?
I do.
Anybody else? Like, okay, fine, whatever your name is. Go ahead.
Okay, so number 1, Brendan and Albert are playing ping pong. Albert lobs the ball and it bounces 3.2 feet high. Brendan smashes the ball, which lands at the end of the table. The ball's position changes at a rate of 7 feet per second. The ball's downward speed is 1.2 feet per second. Find the horizontal speed of the ball, knowing the table's length is 6 feet.
Oh. Thanks, Tanisha. Now you guys go solve the problem. So, what do you guys get? So, Brendan, what'd you get?
Oh, well, I got this this firefighter, and he's putting out a dog.
What is that supposed to be? What does that have anything to do with what I was talking about? What Tanisha read earlier? Oh my gosh, you know, just forget it. Tanisha, I was gonna... Where is she? Where'd she go, guys? Where'd she go?
Yeah, well, she went to the restroom for some apparent reason.
What the freak? And she just... Did she at least do anything at all? Anything?
Well, if you want to consider that anything, she drew this picture of a pig and a house.
The freak? Okay.
Right. So.
Well, do you have anything, Albert?
Oh, me? Well, okay. Let's see. After much deliberation, I have finally come up with a solution. So, we have the picture of the triangle from where Brendan smashes the ball to where the ball lands. Alright? Now, the height at which Brendan smashes the ball is 3.2 feet. It is dropping at a rate of 1.2 feet per second, and the disposition of the ball is 7 feet per second. We also know that the ping pong table is at 6 feet long. Alright? Now then, with this information, we have our givens. X, being the length of the ping pong table, is 6 feet. Y is 3.2 feet, as the height of the ball when he smashes it. The rate of change in the Y direction is the vertical direction at which the ball is dropping, as well as the actual disposition of the ball, dt. Now what we do not have is the actual distance of the ball as it travels along its trajectory, as well as the horizontal rate. So then, let us find our missing variables. One of our missing variables is the distance of the ball, d. Alright, now to do that we have the Pythagorean theorem. 6 being the length of the ping pong table, y being 3.2 being the height of the smash. And with that you're solving for d, you have 6.8 feet. Now we can proceed to find our dx dt, which is the horizontal rate of the ball. We find the derivative of the Pythagorean theorem. We have 2x times dx dt plus 2y dy dt equals 2d times dd dt. You divide the entire problem by 2, you have this equation, and then you isolate dx dt. Now then, after you have isolated the dx dt, you solve for it by plugging in the variables, and your final answer will be 8.573 feet per second.
Thank you, Albert, for being so informative, I guess.
You're welcome.
Why are you eating in my class? This one's full. I'm just gonna keep it. Now you need to do part B.
That was a good PT session. I felt good. So relaxed.
Teacher, read the problem!
Okay!
I hate you. You know what?
Brendan destroys Albert in ping pong. Albert then rage quits and walks off in a tantrum. He slips and falls at a rate of 4.7 feet per second. As he was falling, he makes a 30-degree angle with the ground. Find the rate that theta was changing if Albert is 5.5 feet tall.
Thank you. So, Brendan, you done yet? What do you got?
I got this triangle that shows the situation of the problem. The givens are x equals to 5.5 feet, dy dt, which is the rate of Albert falling, is negative 4.7 feet per second because he's falling towards the ground, and the angle he falls at is 30 degrees. We are finding the rate of which his angle changes. So we'll have the equation tan theta equals to y over 5.5. Once we derive it, we'll have d theta dt times secant squared of theta, which is the derivative of tan theta, equal to 1 over 5.5 times dy dt. Once we isolate d theta dt, we'll have d theta dt equals to 1 over 5.5 times dy dt all over secant squared of theta. Once we plug in our numbers, we'll have d theta dt equals to 1 over 5.5 times negative 4.7 all over secant squared of 30. Once you use a calculator to find your values, you'll have d theta dt equals to negative 0.845 truncated all over 1.333 truncated. Once you use a calculator again, you'll have d theta dt equals to negative 0.641 degrees a second, which is the rate of which Albert was falling at. And that's the problem. Albert, isn't that the problem?
No.
That's the problem. So, well, I guess school's over. See you later.
Let's get out of here.
That's the problem. Oh, hello, Miss Teacher. Hello, Tanisha. Hello, Albert. Oh, you spin the pen so nicely. Okay, well, that's our related rate project. Okay, bye, Mr. Stein.